So you said Einstein's theory of space-time is bullshit.
Well, the thing is, like, the whole idea of space-time is, like, first of all, time is not an actual dimension. It's just a measurement that it's an abstract we came up with. In space, well, space has no actual properties. It's just the lack of something. So what he's really just doing is talking about this, quote unquote, the fabric of space-time. Well, we already have that. We already have a theory for that. It's called ether theory.
Well,
so
we have a method. We have a sort of arbitrary kind of way of measuring time, but time itself is
the problem. Yeah, there's no problem like using time as like a measurement, but the thing is, the problem is he's using time as an actual dimension. Like we have length, width, and height. Those are things.
Height.
Height. Yeah, my bad. Things we can actually travel. Dimensions that we can actually travel in. But he's bringing.
And time is one that we can travel in. We just do it slowly.
But I was like, no. What he's talking about is just time dilation. That's not really time travel. Time dilation is just like you notice how like you spin a record, right? The outside of the record spins a lot slower than the inside of the record. But that's time dilation. But that's not time travel. To travel through time,
but that involves the speed of light and traveling at that speed. Anything with mass can't do that. So. But then we're just appealing to this axiom that has nothing to do with an actual time dimension, whether it be the sun or the space-time is. I mean, as I understand it, space is the thing that in which something occupies, and then the time is how that thing moves.
It's just plot points on the graph.
Yeah, pretty much.
Okay, so anyway, back to my question. So you don't go with theories of space-time. So what do you have instead?
Well, it's a simulation theory. It's just pretty much. It's just like Here, I think I can give you a picture of what the ether looks like. Just give me a second.
That'd be great.
Ether was disproven, though.
Well, maybe he means something different by ether.
No. They made a straw man of ether, which they disproved.
No, how do you figure?
Because simulation theory requires ether theory.
Right, but the theory of ether was disproven.
I'd like to get back to that. But
Strawman.
I'd like to get back to that.
No, it wasn't a straw man.
It was because, like, what they suggested ether was, they thought it was some sort of gas that filled the space of the universe. That's what they thought it was. That's not what it is.
What do you think it is?
Here, let me show you a picture of what it actually is. Give me a second.
I find it funny that you think you know.
Of course I know.
But it doesn't exist.
Sorry, I'm loading here.
Any day now. There we go.
Oh, that's what the ether looks like?
So yeah, this is the freaking ether. Let me sketch.
Looks like
There you
go.
go. That's the ether for you. So this is Right here, the little dot, that's your particle. Here's your string theory, and here's the freaking medium. That's ether. That's the closest thing. That's the closest thing you're gonna get to the image of the ether. In the simulation, there needs to be
literally makes no sense.
So yeah, in the simulation, there needs to be a medium by which everything, quote unquote, exists upon. So all these particles, these little dots, if you actually get the definition of particle, it's just the peak of the wave. That's all. That's all particle means. It doesn't mean a little BB in space.
Okay, so are you thinking the ether's like a quantum field?
The quantum field is just ether theory by a different name.
Okay, I get you.
Here's your string theory. See, how can this little particle over here and this particle over here, this is spooky action at a distance. Oh my God, they're moving together, even though there's the universe is apart. This is string theory. This is spooky action at a distance.
Okay.